Alright, we started drawing pictures of alkanes, alkenes, and alkynes last time. Now we're going to add on our functional groups. So the first thing we're going to talk about is cycloalkanes. What does cyclo mean? Circular, it's in a ring. Okay? So here's our example. Same thing as we did last time. Take the name and break it apart. Cyclo means
circle.
It's in a ring, good. Hex means I have 6 what? 6 carbons. Good. 6 carbons, and all my carbons, bless you, are ane single bonded. Now, do your best. It's not going to look perfect. It kind of looks like a ring. It may be off-centered. Carbon 1, 2, 3, 4, 5, 6. I have a ring of 6 carbons. Chris. What is the ane? They're all single bonds. Six carbons in a ring. What do I have to add to make everybody happy with their 8 valence electrons?
4.
4.
No.
On carbon number 1.
2.
I need to add 2 hydrogens. So just draw 2 lines. If you want to put the H's, that's fine. If you don't want to write all the H's, we don't have to. Carbon number 2 needs what?
2.
2 as well. Carbon number 3.
2.
They all need 2. Good. Fill them out with their 8. So our formula would be
C6.
good. C6H12. You could, like one in the middle. That's fine. As long as they're there, I'll count them.
I don't know who said they like the other thing more, but it's it gets me off the homework, you know, because like
We'll
I
reevaluate.
use the worksheets in class, and yeah.
We'll reevaluate. Example 2. Given a picture, give me the name. Now, the pictures can have as little as this much information. When they're drawn with just lines, at every juncture of a line, we assume there is a carbon. So I have 1, 2, 3, 4, 5, 6, 7, 8. Who was 8? Cyclooctane. Good. I have my 3 different pieces. Cyclo means it's all in a ring. Oct means I have 8 carbons, and the ane tells me they are single bonds. C8. How many hydrogens would need to come off of each one? 2. Good. H16. It's starting to get easier? Good.
What's the methyl and ethyl?
We're going to get there. We okay with cyclo? Methyl and ethyl. Methyl means how many extra carbons do I have? Same spot. Yeah. Meth is 1. F is 2. Now, these are, be careful with this, these are functional groups. These are guys that hang off of your chain. So step 1 is still the same. Figure out what the longest possible chain is. So, drawing a picture for 2-methyl pentane. Tell me what that means.
5. With single bonds.
These ane means it's single bonds. How many? 5 carbons.
Only 1 carbon is ane.
On carbon number
2,
I'm going to have an extra
carbon.
methyl group. That's this. First, draw your chain. Let's do pentane. We know how to do pentane, right? 1, 2, 3, 4, 5. That's my, for now. On number 2, are we okay with this? Everybody good with pentane? On carbon number 2, I have an extra methyl group. What does it look like? Instead of a hydrogen, it would have a carbon.
Wouldn't you want to fill the carbon too?
I do. I have a CH3 group coming off of number 2. Still have to fill the rest of the chain out with my hydrogens. So carbon number 1 would have how many? 3. Carbon number 2 would have, still gets 1 on the top. 3 gets, 4 gets, 5, check again, 5 gets 3. Yes. To fill it out, she wasn't here. Oh. Shouldn't have been sick. To fill it out so that it gets its tetrahedral, because each carbon gets 4 bonds. So this carbon had 1 bond here. I had to add 2, 3, 4 to fill it to get its octet. Instead of filling with dots for the organic, they're hydrocarbons, so they'll just attach with hydrogens. How would you write it? C. Now be careful. This says pent, so you think it's 5, but if you actually count it, we have the 6. H15. Is it 14 or 15? 14. Here's the chain, right? This is my chain. That's my pentane. This 2-methyl business is what hangs off the chain. So your functional groups are the hanging offers, the things that are in addition to the chain. What would it look like? We'll get there. In this picture, what's the longest possible chain? How many?
6.
6?
The third carbon.
1, 2, 3, 4, 5, 6. Anybody see anything longer than 6? 1, 2, 3, 4, 5. So let's number that. This is carbon 1, 2, 3, 4, 5, 6. Take care of the name for 6 carbons first.
What if the CH3 and CH2 at the bottom are connected? Is that possible?
They are connected.
I'm talking about like at the bottom row.
Oh, this?
Yeah.
No.
They can't be.
They can't be. That would make carbon way too happy.
Okay.
It would have more than 4
So
bonds.
you can't ever be in a square or connected like that.
Right.
Okay.
Who's 6? Hex. I have hex. What are my bonds? Single, hex, ane. Good. I'm going to circle hexane. That's my chain. You have a methyl good and an ethyl. So what do we do? Who's this?
No, it's not. It's a methyl.
Methyl. It's a methyl.
That's a methyl group. The methyl group is off of carbon number 2. 2.
So it's with 2-methyl.
2 methyl. Carbon number 2 has a methyl.
3 ethyl.
Good.
Hexane.
Carbon number
3 ethyl.
3 has an ethyl.
So it's 2 methyl, 3 ethyl.
Uh-huh.
What is wrong with like?
No, like, but what's the short way of saying that?
No short way.
There's no shortcut this
It doesn't
time.
even sound
No
like
short way.
2 methyl, 3 ethyl.
So if I went to go to the store, I'd have to say I want 2 ethyl, 3 ethyl hexane.
2 methyl 3 ethyl hexane.
That makes no ethyl.
Next one. Halide. Halide means I have a Halide means I have a halogen, so it can either be fluoro if it's fluorine, or chloro if it's chlorine, or bromo if it's bromine, or iodo if it's iodine. Draw me the picture for, oh my goodness, 111 trichloroethane. Break it apart.
Killing me here.
Break it apart.
No.
What's it tell me?
So we have one,
F means what?
ethyl.
2 carbons. And ane, they are single bonded. So, where do I have space to draw this? 1, 2 carbons, and they are single bonded. That takes care of ethane.
There it is.
And thank you.
Wait, hold on. What's the tri for?
What's the tri for? Tri in the last unit meant 3. I have 3 what?
Chlorine.
I have 3 chlorines. Where do they go? On carbon number 1 and carbon number 1 and carbon number 1.
Oh, it's very explanatory.
It is usually explanatory.
Don't we need to add more hydrogen?
Don't we need to add more hydrogen thingies to where?
Chlorine.
Carbon number 2 gets...
But doesn't the chlorine need something? Because they're
Chlorine needs how many bonds to be happy?
8. So,
How many bonds?
Oh, never mind. Not one.
Just one more.
Yeah.
So it's happy.
Okay.
Now if we did our full Lewis structure, these guys would have the dots around it, but we can simplify it for this unit and we don't have to. Would that be C2, Cl3, H3. Usually we list the H's before the chlorines because they almost always have, I won't take points off, but it's usually written this way because the chlorine is an extra. Almost all the compounds have hydrogen, so we write that second.
But it doesn't matter for us. Right?
Doesn't matter. I won't take points off.
Okay, I'm holding you to that.
I think I'm hating this.
Okay. Okay. Now we go backwards. I give you a picture, you give me the name.
I give you the name or I give you the little letter?
I know.
You can give me the name.
Oh, triane. No, triane.
How many carbons do you see in the longest possible chain?
4.
3 in the chain. There's 4 carbons total, but there's 3 in the chain. Does it matter which way we number it? For this one, not so much. Not tri. What's our prefix? Meth, F, prop. Good. Now, is it propane, propene, or propine? Ane. How do you know that? Okay. I'm going to circle my propane. Looks like a dog bone or something. That's my propane. I have some extra things. What extra things do I have?
We have a methyl.
Good. Austin says I have a methyl.
We have a bromine.
I have a methyl on carbon number.
Oh, right, methyl in front of it, right?
I have a 2-methyl. And what else do I have?
Bromine.
So it's 2-methyl-bromo-propane.
Good. It's like a puzzle that you just have to put together. You're lost.
It sounds like it's...
Hang on. This is a 2-methyl. Where are you lost? Do you see the 2-methyl? This is carbon number 2, and a methyl group is a 1 extra carbon, the CH3 right here, that's hanging off of carbon number 2. Because this was my chain.
Do you enjoy teaching this?
Huh?
Do you enjoy teaching this?
Yeah.
I can't imagine the test of this, because it's going to sound so stupid when you say it out loud.
So what's the name?
Oh, so...
2-methyl, 2-bromo, propane. Next, alcohol groups. All alcohol groups have an OH group hanging off, okay? We changed the name for alcohol by adding OL. All of it. All the different kinds of alcohol would have an OH group hanging off of it. Example 1. Draw me a picture for 2-methyl-propanol.
I don't get this anymore.
Break it apart.
It doesn't make sense anymore.
Focus. Break it apart.
2 carbons coming off it.
Prop. How many carbons in the chain? 3. 3 carbons in the chain. Propane. My carbons are single bonded. Stop there and draw it out. Stop there and draw it out. 3 carbons that are all single bonded. That takes care of propane. The tri tells you how many things there are. Remember the trichloro example? It told you how many. It told you there were 3 chlorines hanging off of carbon number 1. They changed the prefixes just for 1, 2, 3, and 4. Kyle says, I see a 2-methyl. So off of carbon number 2, I have a, what did a methyl look like? CH3. That's my 2-methyl. I have an extra CH3 group coming off of carbon number 2.
This is like a puzzle.
It is a puzzle.
I hate puzzles.
The word ends in OL. OL means it's an alcohol, so there's an OH group. If there's no number, let's throw it on number 1. It doesn't say propan 3-all.
So it would do that.
It would do that. So, off of carbon number 1, we have... Because it doesn't have a number here.
So if it was like 2-all.
If it was 2-all, then it would go right here. If it said 3,
If you walked up to like a bartender and you were like,
he probably wouldn't know.
okay.
Okay.
Yeah, but give me a CH3O4.
Now, what else do I have to add? The hydrogens. How many on carbon number 1? I get 2. How many on carbon number 2? I get 1. How many on 3? So it's C, check it again. Yeah, C3.
Wait, why is it negative?
Wait, why is it C3?
No, why is it negative? Oh, I'm looking at the wrong thing. Just kidding. No, it's C4.
C4, home.
C4.
H6.
1, 2, 3, 4. H. H10 with an O. Or if you wanted to write it C4 H9 with an OH, sometimes it's written that way at the end because the OH group is just kept separate. You can write it either way. Going backwards, here's the picture. Here's the picture, give me the name. It's one of those super simplified ones. So here I have a carbon, and here I have a carbon. So really this guy would really look like that.
What would really look like that?
These are the same thing. That's the same thing. I have a 2-carbon chain. Here's my 2-carbon chain. Off of the first carbon I have an OH. And off of the second carbon I have an OH.
We take baby steps.
Where are we? Same thing. The O is bonded to the carbon, so you can either write it this way or you can put it down here with an OH. But the O is the one that gets 2 bonds, right? Why does O get 2 bonds? It needs 2 more to be happy. So oxygen's going to have 2 bonds. So you wouldn't write it O bonded to an H to a C because hydrogen only ever gets 1 bond. How would I name it?
C2H4.
Oh, we're doing the formula first?
Yeah.
C2H6.
Where are you getting this 6 from? Like,
Look at the OH and the H.
You can count them. 1, 2, 3, 4, 5,
alright, this is broke.
6.
So could you just do like C2H4OH2?
Yep.
Like,
Fine.
keep this the definition of
How would I name this guy? What do I start with?
Alright, ethyl.
Start with S, right? Why S?
Because then we have 2 carbons.
Because we have 2 carbons.
Ethylene.
S, is it ane, ene, or ine? S-ane.
I have a question.
What's our functional group?
I don't know.
It's an alcohol, so it ends in OL.
So it's 2O. Then we have to say where it is.
Do you have to tell me where it is? Yes.
It's 2OL.
It's 1 and 2.
It's 1 and 2. If there are 2 of them, mono, di, tri, di.
Why does it die this time?
Why does it die? Because how many do I have?
Well, yeah, it means 2, but why
I
wouldn't
have
it be
2 groups.
third time?
Next.
Carboxylic.
Carboxylic acid. A carboxylic acid has a carbon that looks like it has an alcohol group, but that same carbon has a double bond to the O. Carboxylic acids end in oic acid. So, let's try one. I have 3-methyl butanoic acid.
Alright, pause.
Pause.
Wait, you lost me here.
It's the rest of the molecule. R stands for whatever the rest of the molecule is. But is 4. I have 4 carbons. Butane. They are single bonds. Draw them out. Carbon 1, carbon 2, carbon 3, carbon 4. Do this one. Are we okay with butane? 3-methyl. What does that mean? On carbon number 3, I have a methyl group. I have an extra carbon. Good. My methyl group was a CH3.
Okay,
Never mind, we're good.
Okay?
we'll survive.
Good. And this guy ends in
Oic acid.
oic acid. Whenever you see the ending in oic acid, that means my picture has to look like this. Is there a number here? No, so it goes on carbon number 1. So carbon number 1 has to have a double bond with an O, and then an OH. Oxygen gets 2 bonds, so 1 is carbon and 1 is hydrogen, so he's happy.
We have to put the R joint?
No, R is the rest of the molecule. In this case, R would be carbon 2, 3, and 4. R would be this. R would be the rest of the molecule.
Is it still right if I put O on the bottom?
2 more slides.
Yes, fine. Yes.
Next slide. Next slide.
What else am I missing?
Oh, we gotta put the carbon too. We have to have
Carbon 2's got to get
2 hydrogens.
2 hydrogens.
Carbon 4 has to get 3.
Carbon 3 has to have
1 more.
1 more. Carbon 4 has to get
Trace.
3 more. Whoops.
I'm done.
Hey.
I'm not coming back in here today, Deibler.
Okay.
Mentally, I just wanna sleep.
What would my formula be?
B5, H10. No.
Oh, something. Yeah, so an O in there, right?
And then O2.
3, 4, 5, 6, 7,
C5H10O2.
What? How's it?
Yep.
Going backwards. Here's a picture. At every dot, there's a what?
Carbon.
There's a carbon.
8 carbon.
What is that? That means this is a double bond, that's a single bond, this is a double bond, that's a single bond, double bond. Who is this?
It's a cyclo.
It's a good cyclo.
Hex.
Hex. Pause there.
I can't.
Everybody see that that's a cyclohex.
Oh, because it's in a ring.
Good. Cyclohex. Ein, ein, or ein? Ein. Why? Good. There's double bonds right here.
Okay, that's a terrible double bond. It does not look like a double bond.
That's a second line.
Wait, it's not in between, it's like inside.
Right.
You don't like saying
No, it's not.
Good.
No, one, three.
What's this? It's a carboxylic acid. How do they end?
Oic acid.
Oic acid.
That's a bet.
All I want.
That would be a cyclohexenoic acid. Why cyclo? Because it's a ring. Why hex? It's a ring of 6. Why ene? They're double bonds. Why oic acid?
Yeah, I have a question.
Double bond, that's what the
I have a
extra in
question.
the middle is. Double bond.
Why we didn't tell where the double bonds go?
For that guy, we don't have to. That would be too crazy. Formula.
I really don't think anyone understands.
Formula.
C6.
No, C7.
Aren't you special?
H. Now we gotta figure it out. Ready? This carbon has how many bonds? 1, 2, 3, 4. He's happy. This carbon has 1, 2, 3, 4. He's happy. This carbon has 1, 2, 3. So I need 1 hydrogen there. This guy would have 1, 2,
One more.
3. I need 1 more here.
That guy's gonna need 1.
That's gonna need 1. 1. 1.
So we have
C7H6. 6. O2. Going back to that question that was on worksheet 1. Saturated versus unsaturated. What's the difference? Saturated is everybody's full of single bonds. Unsaturated, somebody has a double or a triple bond. Now, why is this unsaturated? What can happen?
if you're saying one or more double or triple bonds.
It can break and something else can form right there. So which is healthier for you to eat if we're talking about fats? Unsaturated. Why? As it goes through your body, it can break down easier. Things can attach to it. That sounds like biology. Saturated fats are the bad kind for you.
Like the stuff that's in
Unsaturated. Avocados, nuts have good fat in them.
So like candy bars, they have bad fat?
Candy bars would be more of the bad saturated fat. It's harder for your body to break down.
I'm sorry, buddy, I had to kick that this morning. Next slide. We done though, Kyle.
Different ways to represent things. You can have a formula. What does the formula tell me? How many carbons and how many hydrogens? That's pretty much it. It's like, yeah, it's the recipe. It tells you how much you have. What doesn't it tell you?
How many bonds?
The number of bonds, what it even looks like. So then you can go to the structural model. We call this the Lewis structure, right? This tells you the bonds. This is how I will write them primarily on your quiz and test so that you can get the most information out of them. The skeletal model does what?
Show shape.
It simplifies it, right? You have to, in your brain, add things to that. You have to say at every junction there's a carbon present, and then you have to fill out the hydrogen. So there will be some of these on your worksheet, or if you are comfortable with this, you can draw them like this. That's okay. But for the quiz and test, I'm going to focus on the ones that look more like Lewis structures.
I'm guessing that space filling model shows
That was
placement?
every other one. Yeah, every other one. Space fill is what it really looks like, right? Because all my electrons are in clouds.
Sorry, I'm just moving. My legs are stiff.
All the electrons are in clouds.
Come out of the gutter.
And how does something bond? How does a bond form? I share my clouds, right? If I'm sharing my clouds, I have to be close enough to touch, right? I don't have bonds forming in my electrons aren't traveling down little springs or wooden sticks like we had in the lab. No.
So we won't ever have to write the space filling model, really?
No, you won't ever have to draw the space filling model. This is optional. That's up to you. If you get it that way, that's fine. Primarily, we're going to focus on the Lewis structures.
And we wouldn't get it wrong if we did the dots.
No, if you want to add dots, that's fine. Okay. Homework is?
Worksheet 2.
Worksheet 2.
Can we go on to them?
Nope.
Why not? Why not? Why can't we?
Don't ask why, Austin.